of those equations matches the picture. So, what's your thought? What are you thinking about maybe doing? No calculator problem, so we're not going to be able to graph it. Find a point. All right. So, what is a point that we don't have to approximate? What is a point we know for sure and don't use zero? What is a point we know for sure? So, actually, it would be 6, 3 pi over 2, right? 6, 3 pi over 2. Would everybody agree with that?
Wait, why is it 6?
Look at, okay, I'm on example 3. How big is the outside circle?
Oh. Never mind.
You good?
Yeah.
Okay, we're on page 6, example 3. Would everyone agree that that point is plotted on the graph? Okay, so let's check some equations. R equals 2 plus 4 sine beta. All right, what is the sine of 3 pi over 2? -1. That will not add up to 6, will it? So it's not that equation. All right, R equals 2 minus 4 sine. What's the sine of 3 pi over 2? -1. That does equal 6, doesn't it? Let's keep going just to make sure. R equals 2 plus 4 cosine. What's the cosine of 3 pi over 2? 0, that's not going to work. And that's not going to work either because the cosine's still 0. So that is the only option that we have right there. Does that make sense to you on any level? Look at the picture. What symmetry does that picture have? Vertical axis, y-axis. And we, I think, mentioned yesterday that sines are going to have that symmetry because sine is y, right? So it makes sense perfectly. That shape, by the way, is a lima sign, just like we ran into yesterday. But this lima sign is not a cardioid because it has a little loop inside of it. All right, next. A portion of the graph is shown. All right, so here's the equation, but this time he didn't graph the whole thing. He only graphed part of it. Normally, to get the whole picture, we would go from 0 to 2 pi. That would give you the whole picture all the way around. He wants to know what section, not 0 to 2 pi, what little interval did we actually graph to get that piece of the picture? Well, this is our equation. Let's look at our first option. Our first option is basically 0 to pi over 2, that part of the graph. Well, let's see. If we put 0 into our equation, what do we get? What's the sine of 0? 0. Sine of 0 is 0, right? So we would get the pole. And that's good, we got it, right? Now, let's put in pi over 2. What's the sine of pi over 2? 1. So that would be -3. So that would be plotted down here, right? Well, that looks okay. That looks like it could be a possibility. So let's hang on to that one. this one, A, could be a possibility. All right, let's look at B. B is pi over 2 to pi. All right, if we put pi over 2 in, we put pi over 2 in here, we get -3, which would get plotted down here. That looks okay. Now, what if we put in pi? We get 0? That one could be a possibility too. Let's try C. C is a 0 to pi. Alright, so what happens if we put in 0? We get 0. What happens if we put in pi? We also get 0, so I think that's not good. And how about pi to 2 pi? Isn't the same thing gonna happen there? We're gonna get 0. So it's one of these two. Alright, we need to figure out which one it is. Any thoughts on how we might do that?
Flip it over to take out the negative, and just see which one looks like a normal sign. Like a normal sign curve.
Well, now remember, when we think about a normal sine curve, that's rectangular.
I mean like the normal sign, like how it does the flower shape, and there's no nice little.
Okay, I think I'm following Charlie.
Could we just find another point and use that?
How about that? How about in this interval right here, what would be a good point to pick? In that interval, a good point might be pi over 4?
Yeah.
Okay, so I'm just gonna try pi over 4. Now, I know that the sine of pi over 4, and pi over 4 would be plotted right here. The sine of pi over 4 is root 2 over 2, but I'm multiplying it by a negative. So whatever wacky decimal that will be, it'll be a negative number. Would you agree if I put in pi over 4, I get a negative? Which means it would have to be plotted over here. Is that part of my picture? No. Now, just to show you that this is good, it's the only one left, so it has to be, but let's try 3 pi over 4. If I put in 3 pi over 4, again, I get root 2 over 2, which is some decimal. But when I multiply it by a negative, I get a negative. So 3 pi over 4 should be plotted here, but because of the negative, it's going to be plotted down here. Does that make sense in terms of my picture? Yes. Yes. Very good. All right, you and your partner try 5, and then we'll start with you. You and your partner try number 5.
What is this?
You're right. I'm walking on.
That's really, I've never heard anybody say that.
You gotta watch those. The computer green, like green.
For what?
So kind of zero.
Oh, yeah,
I don't understand, so I got negative 3 0. How to do it.
Leo, are we focused on this problem, Leo?
I finished. I got my third.
I need to.
But wouldn't it be though, this is negative 3 pi, negative 3. Yeah, but wouldn't it convert to add a pi? I don't know. Yeah, because she said negative 3 0. Be right there, yeah.
I don't even know how to like.
Are you talking about C or D? First, I do. No, cosine. I is over here. Oh, yeah, you're right. So it is.
I read no
If you're totally. I don't work my algebra. Did you bring a tablet? Did you bring a tablet?
No,
Understand? I brought my.
okay, so I just took whatever intervals he gave me and I evaluated my equation at those intervals. And I actually got these 2 points for 3 of them. This one, I got the same point twice, so I ruled out C. But now, I don't know, it's one of these other ones, so I'm gonna pick a number in between. So let's see, this is 1 and 1.5. So what might be a number that I could pick in there, one of my angles I could pick in there?
-3, then how's the point on
Which one might
for A? So 3 cosine of 3 pi is equal to -3. So how is the point on the positive 3
Because
pi?
when I plugged in pi,
Yeah.
I got a negative. Pi should be plotted here,
Yeah.
but because I got a negative, it gets plotted on the opposite side.
Oh.
Remember?
Yeah.
Yeah. So I put in pi, so I should be plotting right here,
Yeah.
but I got a negative answer, so. Alright, so, how about, is 5 pi over 4 in there? I'm gonna try 5 pi over 4, okay? So if I plug in 5 pi over 4, I'm gonna get 3 cosine 15 pi over 4, which is 3 cosine 7 pi over 4 if I get rid of the extra in there. Now, 5 pi over 4 is the number I plugged in, so I should be plotting right here. Is the cosine of 7 pi over 4 a positive number or a negative number? Positive. So it's gonna get plotted right here. Is that where I want it to be plotted? No, so it's not that one. All right, now I'm gonna try here. I'm gonna put in pi over 4. Now pay attention, guys. So I'm plugging in pi over 4. So I have 3 cosine 3 pi over 4. But the number I plugged in is pi over 4, so it should be plotted here. That's pi over 4. Tell me about the cosine of 3 pi over 4. It's negative. So it wouldn't be plotted up here, it would actually be plotted down here, which is not where I want it to be plotted. All right, let's try pi over 12. Pi over 12 should be plotted right there. If I plug in pi over 12, I get 3 cosine pi over 4, which is a positive number. It's gonna get plotted right there, so your answer is E. Okay? I think there's one more of those we'll do next time, yeah. And then we'll be ready to move on from that, so. All right, let's get our review sheet back out. Did anybody find anything we still need to talk about in terms of the review?
Maybe 1B.
1B. It is a calculator problem. And basically, guys, why do we need calculators? We would not ever need a calculator except for what? What is the reason we have to have it? Because our angle isn't going to be on the unit circle. We're going to get some kind of funky angle, and we'll need to figure out what it is using our calculator. That is the only reason we need it. All right, so 3 tan squared minus tan minus 10. And remember, this direction right here simply means I don't have to do that plus 2 pi k squared.
Right, this interruption is at the time, so choir members should be excused from class to get ready for station with the cross. Thank you.
Okay, so what do we do first? Factor. How does this factor? Well, my choices are limited, either 5 and 2 or 10 and 1. So how about 5 and 2? Because that'll give me -6 and +5. It takes a minute to figure out the factoring, but you guys can do it. All right, now what does that mean? That means the tangent is -5/3, or the tangent is 2. Each of these are gonna have 2 answers, because there are 2 quadrants in which the tangent is negative. Right? And then there are 2 quadrants in which the tangent is positive. All right? Now, the actual answers to the problem are going to be the pink and the blue. Those are going to be the answers. But I can't find those. Those are going to come from doing something to this angle right here. I'm going to find that angle right there, which is going to be the same as this one. All right? So second tangent, 5/3. Don't worry about the negative, because you already handled the negative by drawing your picture in these quadrants. You just want to know what angle has a ratio 5:3. So I got 1.030. Is that what you got? Okay, now, 1.030 is not an answer. How am I gonna find the pink answer? Pi minus 1.030. And how am I gonna find the blue answer? 2 pi minus 1.030. Just look at the situation. Use your common sense. So for pink, I got 2.111. And for blue, I got 5.253. How do those look? Everybody okay? All right, now I'm gonna rinse and repeat here. The only difference is, this time, pink is gonna be the answer on my calculator. And then blue will be found how? Add pi. Yeah, take whatever I get and add pi. So, second tangent 2, I got 1.107. So pink is 1.107, and blue is 4.249. All right, on the calculator problems, everything hinges on what we call the reference angle. Then you can manipulate it into whichever quadrant you need it to be. All right, we got that okay? All right, that one. All right, anybody have another one? Yeah,
The one on the back of the page, of the first page, the range.
what is the range? So E on the back of the first page says we have this equation. So again, cosecants are not part of my normal, like, I don't know, I just don't think much with cosecants. So I'm gonna think about, what does a regular cosecant look like? What am I starting with? Before I make all these changes to it, what am I starting with? Well, remember, the cosecant is the reciprocal of the sine. This one happens to be upside down. So my normal sine curve, upside down, would look like this. Everybody okay with that? Normal sine. When I do a cosecant, I have to reciprocal that. So every time the sine is 0, I have an asymptote. And then I flip the curve. Now that is a normal cosecant. So, I've already flipped it upside down. What is that going to do to it? That's going to make these 2's, right? What is that going to do to it? Up 3, so instead of this point being at 2, it's now gonna be at 5. And instead of this point being at -2, it's now gonna be at 1. Now notice, I'm kind of ignoring that, because what's that gonna impact? The asymptotes, which will have nothing to do with the range, right? Nothing to do with the range. So, what is my range? Celeste, I'm going from 5 to infinity. It's red. So 5 to infinity, or from -infinity to 1. And those can be in either order. It doesn't matter which one you do first. That's your range. All right, what else? Yeah.
J, 2J, it's on the back of the second page.
When this is solved. All right, so we're doing the one. That says, solve sine 2x equals 2 sine x. And we're between 0 and 2 pi. First of all, those are not the same thing, right? Everybody understands that? Those are different. Second of all, it's not solvable the way it sits without a calculator. It's not solvable the way it is right now. I have to make a change. What do I have to do? Get rid of the 2x. What do I know about sine 2x? This has gotta go. This doesn't match this, so I gotta get rid of this. What does sine 2x equal?
2 sin x.
Good. 2 sine cosine, that's exactly right. Now, what are we not gonna do? We are not gonna divide. No. What are we gonna do instead?
Fold the 2 sin x over.
We're gonna pull the 2 sine over. And then what?
Why can't you divide out the 2?
You can divide out the 2.
Okay.
You can absolutely divide the 2. If you want to divide out the 2, just the 2, that's legit because it's just a number. But don't divide by that cosine. Alright, so if you've already gotten rid of the 2, that's fine. It's going to disappear here in a minute anyhow. What do I do next?
2 sin x.
Yep, I factor it. My GCF. Now, each factor is equal to 0. So 2 sine equals 0, or cosine minus 1 equals 0, right? That's what we do. After we factor, we set them equal to 0. So now the 2 is going to disappear, and it's just going to say sine equals 0. Where does that happen? That the sine equals 0. 0 and pi. And because the instructions are written that way, I'm not going to include the 2 pi, but I could if it were bracketed. All right, where does the cosine equal 1? At 0, which I already have, so that's it. Those are the answers to the question. Is that okay? By the way, to even start this problem, you had to know this, right? We gotta know those guys, gotta know them. That brings me, I don't know if you had a chance to try it yet, but in F, look at number 5 in F. So it's cosine 5 pi over 12. How are we gonna do this? No calculator. Pi over 12 is not on my unit circle, so what do I do, Charlie?
Either add or subtract by it.
Yeah. So can you think of anything, Charlie?
Well, let me see, could do, well, yeah, what might,
One option, if you're struggling a little bit, these are our unit circle angles, right? Make them 12ths. So I've got 2 12ths, 3 12ths, and 4 12ths are my main angles. So is there any way I can combine any of that and get 5 12ths? I could add these two. So cosine pi over 4 plus pi over 6. Now remember, if this guy's bigger, you can come over here and use these two. You can use any of them, right? You're not restricted to quadrant 1. Okay, everybody good so far? All right, here we go. How do I do cosine angle plus angle? Cosine of the first, cosine of the first, cosine of the second, minus sine of the first, sine of the second. Cosine, cosine, minus sine, sine is our identity for the cosine of alpha plus beta. All right, now I'll start plugging them in, here we go. The pi over 4s are root 2 over 2. What's the cosine of pi over 6? Root 3 over 2. And 1/2. And we end up with root 6 minus root 2 over 4. Everybody okay with that? Quick comment, in the homework, I forgot what section that was, but in the homework, one of the problems was like, find a secant or cosecant, and you did exactly what I, told you to do. Like if this problem had been, what's the secant of 5 pi over 12? I would do this exactly, but then when I got down here, I would flip it. Now, something to keep an eye on is that really reduces. I mean, it reduces nicely. If you multiply the top and the bottom by the conjugate, what does the bottom end up equaling? When you FOIL that out, what does that end up equaling? 4. Isn't it 6 minus 2? And then these will cancel, and so the answer is just root 6 plus root 2. These guys, when you flip them, will always reduce. So it's kind of like, sometimes you, like if the cosine of pi over 4 is root 2 over 2, the secant of pi over 4 would be 2 over root 2, but that reduces a lot easily. That's just the same as root 2. So those obvious reductions you want to make. So flipping this will always reduce, flipping that will always reduce. All right, anything else you found that you want to talk about? Yeah,
Can you do 7?
which one?
7 or under it?
Number 7, so the angle whose sine, the angle whose sine is root 3 over 2. Now, the thing, again, more stuff to remember, there's so much. This notation immediately means you are only looking at this part of the circle. Since that's a positive number, I must be looking up here. Because down here, the sign is negative. So my angle's up here. The sine is root 3 over 2, so it must be that ordered pair. And that ordered pair is what angle? Pi over 3. So the answer is pi over 3. Remember, if that had been a negative, then you'd be down here, but you must answer negative pi over 3. Do not say 5 pi over 3, because in order to get to 5 pi over 3, wouldn't you have to come over here in this part of the circle? And this doesn't exist. This is like a black hole out here, all right? Nothing out there. So with inverse sine and tangent, if you're down here, your answer must be the negative. All right, anything else?
Okay. I don't know if this works or not, but for number 8, when you were like, yes, just right below it, when you did the thing where like, you made pi over 6, like 2 pi over 12 or whatever,
Yep.
since it's only from 0 to 2 pi over 12, could you divide the sine of 2 pi over 12 by 2?
It's not linear, no. We wish it were, you can check that on your calculator, take your calculator out. put it in degrees. And let's pick it and put it in degrees, it'll be easier. Why are you using that calculator?
I just make up for business.
Yeah, but we're not gonna have to reduce anything, so. Okay, so go to mode, put it in degrees. Mode. Okay, put it in degrees. Okay, so what you are asking is, let's do the sine of 80. Okay, there's the sine of 80.
Yeah.
And is the sine of 40 just gonna be half of that? And it's not, yeah. Now, let me put it back in radians, because it's not supposed to be in degrees. Okay. All right. Anybody else have questions? All right, I wanna do one more, I gotta find one. I wanna do another inequality. We did one yesterday. So let's do one more inequality. Just because we gotta make sure we're remembering our steps. And I don't remember, I don't remember the one we did yesterday. Okay, so here we go. What's the first thing I want to do? Factor? Here we go, we're gonna factor. I'll do this quickly here. Does that look about right? This problem is not on your sheet. I made it up.
Oh.
There's only one inequality on your sheet, and I want to practice another one. So this is just another problem. Everybody okay? Now, what are my key values going to be? Well, sine is going to be -1/2, and sine is going to be 1. Now, this is an inequality, so I'm going to be drawing and shading on my unit circle, but my dots are going to be located here. So where is the sine -1/2? The sine is -1/2 at 7 pi over 6, very good, and 11 pi over 6. I'm figuring out where my dots are going to be. Where is the sine 1? Pi over 2. Okay. Now, here comes the tricky part. This is an inequality. These two things multiplied are negative. So what does that mean? One is bigger than, and one is greater than, and one is less than. So, sine theta is less than -1/2, and sine theta is greater than 1. So this is the less than, greater than. The other one will be greater than and less than. And of course, the order you do those is irrelevant. Okay? I already know where my dots go. My pink dots are going at 7 pi over 6 and 11 pi over 6. Right here on that line. I want to be less than that. So won't this be my pink? My blue dot is here at pi over 2. I need to be greater than that, and I can't. So therefore, this has no impact. because to be an answer, you have to be pink and blue. Alright, dots are in the same place. So my pink dots, 7 pi over 6, 11 pi over 6. This time I'm shaded above. Blue dot is a pi over 2, and I'm shaded below. What is my answer? When you do this, you gotta start at 0. So you're gonna go 0 to pi over 2, pi over 2 to 7 pi over 6, and then 11 pi over 6 back to 2 pi. Remember, you start at 0 with your answer and work your way around. Okay? Stuff stays here unless you brought a blanket or something to sit on. You're going to take that. Everything stays here. You go out to the courtyard and have a seat. You can sit anywhere you want. It's like not roped off. But be good. We'll be watching for you.